Today we're going to review everything about linear equations that we learned last year. So we're going to be practicing that. We'll do a quick little notes and then we're going to practice it. So first let's go over the key concepts of linear equations. First and foremost, the rate of change or slope. So the rate of change or slope, you can use either word for linear equations. It means the same thing. It's always between two distinct points. Always 2 points, so x1, y1, x2, y2. How many points do you need to find slope? It's always 2. They give you 5 points. All right, pick 2. You always just need 2. So there's a lot of different ways of thinking about slope, but they all are equivalent. So you could think about it as change of dependent variable over the change of independent variable, dependence y, independence x. You could also think of change in y or change of x, or this is a different way of writing change of y over change of x with the delta sign, vertical change or over horizontal change, because vertical is up and down y, horizontal is right and left, which is x. Rise over run, you go up or you go down, and you run right or left. It's all similar ways of saying slope. I'm sure your teachers have said multiple of these. And the official slope formula is y2 minus y1 over x2 minus x1. So what does y2 mean? Well, that little subscript, that little number in the bottom right, it tells you the location. So y2 is coming from the second point. So I labeled this point to be the second point, and I labeled this point to be the first point. So my second point, I said the coordinates were x2 and y2, and my first point, x1, y1. So if I were to find my slope, I would plug in y2, which is let's first find these points. So this would be 4, 5, and this one over here would be -2, 2. So we're going to plug in each value. So y2 is 5, y1 is 2, so 5 minus 2 over x2 is 4, and then this one's careful. This one's very important, so be careful with it. x1. You have the minus sign, and then x1's a negative, so it's 4 minus a -2. Make sure you always insert negative values with parentheses. So that will tell you, oh, I need to distribute that negative, keep change, and I get 3 over 6 as the slope, which is really just 1 over 2. And that's my slope of this line. And the first question I always get is, what if I wanted to make this point x2, y2, and say it was my second point? And what if I made this point x1, y1, and made it my first point? Why did you choose that to be the second point? Well, it doesn't matter. As long as x2, y2 corresponds to the same point, and x1, y1 corresponds to the same point, you're good. And I'll show you that we'll get the same slope. So we'll do y2, which is 2 in this case, minus y1, which is 5, over x2, which is -2, x1, which is 4, minus 4. We would get -3 over -6, which is 1 over 2. So you get the same exact slope. It doesn't matter which one you say is 0.1 and 0.2, but I just have to make sure when you guys are finding the slope here, make sure you line it up with the same point. So if you put y2 first, then you have to put x2 first. You can even put y1 first if you want to, but then you have to put x1 first. So you could even write the equation like this, y1 minus y2, but then it would have to be x1 minus x2 on the bottom. So that's a little review of slope. Let's go down to the slope-intercept form of the line. So it's one way of showing the equation of the line. What does the m represent? So here's the slope-intercept form of the line. This is what we're going to be using most of the time to show a linear equation. And each of those values means something. So what does the m mean? M is what we use to show slope. And slope, let's write that equation just one more time. y2 minus y1 over x2 minus x1. What's the b in this case? The b is the y-intercept. So b is the y-intercept, and that's where it crosses the y-axis. So that would be right here. Now, how about the x and the y? X and the y, this is important for understanding how to find the equation. We never plug in for the x and the y unless we're trying to find the slope and the y-intercept. So the x and the y are all the points x, y on the line. So it's every single point on the line is x and y. So how would I write the equation here? Well, we plug in for the m and the b. Those are the two values we need to find. So we can find the b first here. So the b is where it crosses, the line crosses the y-axis. So the b is at 2. So I know one value. It's y equals blank x plus 2. And then find the slope of the line. I'm going to choose 2 points. I'm going to choose this point and this point. I'm going up 1 and then to the right 2. So my slope would be up 1, 2, 1 over 2. So that's the equation of my line. Y equals 1/2 x plus 2. So that's slope-intercept form. Now let's do point-slope form. So if you take a look at, before we get to point-slope form, if you take a look at slope-intercept form, it's called slope-intercept form for a reason, because you plug in for the slope and the y-intercept. Now point-slope form of a line is called point-slope form because you plug in for the slope of the line and also one of the points. So m stays the same, it's slope, which is y2 minus y1 over x2 minus x1. And here's where this formula changes a little bit. The x1, y1 is a specific point x1, y1 on the line. Whereas x and y stay the same. They're all the points on the x and y. So it's all the points xy on the line. So for point slope form, if I want to put this line in point slope form, we don't need the y-intercept here. We just need any old point. So I'm first going to find the slope. Well, it's the same line as above. It's up 1 and to the right 2. So my slope is 1 over 2. And then just pick a random point. I'm going to pick this point right here, which is 6, 5. And you plug that point in for x1 and y1. So our equation in point slope form would be y minus, my y1 here is 5, equals 1/2 my slope, x minus 6, which is my x1. So this would be my point slope form of this line. Let's go on to the next page. What should I be able to do by the end of the day? I can write a linear equation in slope-intercept form from a mathematical description, an XY table, a graph, or a real-world description. I can graph a linear equation, and I can find the rate of change of any linear relation. So let's all review. Should be able to do that already, but we're going to review that so we can knock out any of the cobwebs. So without a calculator, for the first two at least, we're going to use a calculator for the last graph. I want you to graph y equals negative 2x plus 3. So when you look at this one method, so method 1, is just using the y-intercept and the slope. So I know the slope is negative 2, or you can write it as negative 2 over 1. I know the y-intercept is 3. So I'm first going to plot my y-intercept, which is at 3, which is right here. And my slope is negative 2. So negative 2 means I go down 2 and to the right 1. So down 2 to the right 1. Rule of thumb is you need to plot it at least 3. I would plot every single point you can. And also, it could be 2 over negative 1. So you could go up 2, but if you go up 2, you have to go to the left 1. So we can plot right here, here, and here. Just because you want to make sure your line goes through every single point and doesn't drift off. So I draw my line. Put arrows on the end, make sure the line's going all the way through the graph, and you label it, and voila, you're done. If you do it this way, there's one thing I want to make sure you check, and that is because I see this mistake a lot. Look at your slope. My slope's negative. Look at your line. It's going down. Okay, check. Good. Always check to see what way your line is going. If it's going up, you should have a positive slope. If it's going down, you should have a negative slope. So if you know you have a negative slope, and when you check your line, it's going up, you got to erase that and do it again, because it should be going down like this line is. Now, a different way is using a table of values. So method 2, we have a table of values. So on the x side, you just want to put x values on the left side of this table that you are going to be able to graph. So I'm going to put one that's not able to graph, so you see what I mean. So let's do negative 1, 0, 1, and we'll do 10. And we're going to find the corresponding points, the corresponding y values to these x values. So I'm going to plug negative 1 into our equation. That would be negative 2 times negative 1 plus 3. That's 2 plus 3, which is 5. So this point would be negative 1 comma 5. You can plot that. Plug in 0. You get 3. So this point would be 0 comma 3. Plug in 1. This point would be 1 comma 1. See how we're able to graph all of these? Watch when I plug in 10. That'd be negative 2 times 10 plus 3, which is negative 17. That's completely fine to show in the table values. That's not wrong. That's completely 100% correct. But that's going to be like down here. We can't actually graph that on our graph unless we change the scale. So you can change the scale if you want to, but I'm not going to include 10 because I'm going to want to plot one more point. Let's just do 2. Keep it simple. So that'd be negative 2 times 2 plus 3, which would be negative 1. So that point would be 2. Oops. 2 comma negative 1. And 2 comma negative 1 would be there. Now, I just like to make sure I plot every single other point that follows that pattern. Draw your line. Make sure it's going all the way through the graph. Arrows on the end. Label. And that's your line. So this method 2 is a method your calculator does, but it does a lot quicker, gives you every single possible point. So let's go to the calculator and let's get our table of values that way. So that's what we're going to do down here. So before we do the calculator, just take a quick look at the two graphs we just graphed. Notice they're the same exact line. So it doesn't matter which method we choose, we're always going to get the same line. So you can do method 1, just the slope and the y-intercept. You could do method 2, which is table of values, or you could do the third method, which is table of values with the calculator. So get out your calculator. And what we are going to do is we're going to graph our equation. So you go to y equals, clear anything out that's in there, press negative, because it's -2. Careful, do not press minus. That's different. The minus sign over here is for subtracting. The negative next to enter means negative. So that'd be -2x plus 3. There's our graph. Looks exactly the same. But how am I going to use this to show my work to graph this line on a piece of paper? Well, if you press second graph, second is blue, so it brings up the blue command, which is going to be table. And here it gives us the XY table. So what we could do is just copy this down onto our, we don't need to copy down every single point, but let's copy down at least 3 points in an XY table here. So I'm going to do -2, -1, 0, 1, and 2. And their corresponding y values would be 7, 5, 3, 1, and -1. And plot all those points just we have been doing. And I would continue to plot every single point we can, just so we're as accurate as possible. Draw a line. Arrows on the end. Make sure you label y equals -2x plus 3. And that's all you would have to do if you're using the calculator. Notice it's the same exact line as the ones above, so you can really use either method. So let's now look at, is the point -24, 59 a solution to the equation? There's a couple ways about going about this. So you could either plug in the x and the y into the equation and see if it works out. So that would be 59 is my y, equals -24, which is my x, times the slope, which is -2, plus the y-intercept, which is 3. And you get 59 is equal to 51. That is not true. 59 is not equal to 51, so we have to go back and change it. It's not equal to. So is the point a solution to the equation? No. So is the point on the line? No. And you could check that also if you want to use a calculator. You could go to the, scroll up until x is -24, and you would see at -24 it should be 51, which we got, and yes it is. It's not 59, so -24, 59 is not a solution to the equation or on a line. On the next page, I just want you guys to do the do now, which is 1 through 7. Pause the video and take 5 to 10 minutes. Take your time on this. This is the majority of the lesson. And play the video once you're done and we'll go over the answers. So number 1, I want to get each equation into y equals mx plus b form. That means I need to get the y all by itself. The y is not by itself here. First thing I need to do is subtract 4x on both sides. So now we're left with -6y is equal to -4x plus 17. All right, we're getting there. And then we just got to divide by -6 on both sides. And now our y is going to be by itself. So that'll be y equals to -4 over 6x minus 17 over 6. And I'm just going to simplify negative 4 over 6. Oh, sorry, it'd be negative 4 over negative 6. You might have caught that. So that would be y equals negative 4 over negative 6. We'll simplify to 2 over 3. X minus 17 over 6. And that would be our simplified linear equation y equals mx plus b form for number 1. Number 2, I just like putting, whenever we have like math words, I'm going to put the math symbols right underneath them. So the output is y. Is means what in math? Equals. 3 means 3. Less than minus twice, 2 times the input, which is x. But the big difference here is whenever you see less than, you need to flip the order. So instead of 3 minus 2x, it's 2x minus 3 equals y. So whenever you see less than, make sure you flip the order. That is key. You're going to see that a lot of questions use less than for the wording. So it's subtracting, but you have to flip the order. Number 3, it passes through negative 4, 7 with a slope of 3. So I'm going to first write my equation y equals mx plus b. Let's plug in what we can. So we know we have to plug in for the m and the b, the slope and the y-intercept. Do I have one of them? Yes, I have the slope, so I know that's going to be y equals 3x plus b. Well, I don't know the y-intercept, but what we do know is we do know a point xy, so we can plug that point in for x and y in our equation. So that would be 7 equals 3 times negative 4 plus b. And why does that help us? This is a very crucial concept for math for the rest of your math career. Well, it helps us because now we can find the b, because all we have is one variable now, b. So now we can solve for that variable if there's only one variable in the equation and figure out what it is. So 7 equals negative 12 plus b. Add 12 on both sides, we'll get b is equal to 19. So now we have b, and we have the slope, which is m, so y equals 3x plus 19. That's crucial. We're going to be doing that a lot, so you always want to get the equation down to one variable so you can solve for that variable. Let's look at number 4. So number 4 says a line that passes through 2, 5, and 4, 9. Well, I know I got to get this into y equals mx plus b form. I don't know the slope. It's not giving me the slope. It's not giving me the y-intercept. Okay. What could I do with 2 points? Well, to find the slope, you only need 2 points. So let's find the slope. M equals y2 minus y1 over x2 minus x1. I'm going to label this x1, y1, x2, y2. I just don't want to make any mistakes where I incorrectly plug in. So that would be 9 minus 5. And then x2 is 4. x1 is 2. You would get 4 over 2, which is 2. So I know my slope is 2. So it'll be 2x plus b. We have 3 variables in this equation. That's not going to help us solve anything. So let's do what we can to get it down to one unknown number. So I take a look at y and x. Well, I have a y and an x point here. And I also have one here. Just choose one of them. I like to choose the smaller numbers and make sure they're both positive so I minimize my mistakes. So I'm going to plug in the 5 in for y. Make sure these points are coming from the same point. So 5 comes from the y, the first point, and then the x is 2 coming from the first point plus b. You get 5 equals 4 plus b. So subtract 4 on both sides, you get b is equal to 1. So now we have the slope, we have the y-intercept. My line is y equals 2x plus 1. Number 5. So we have to, again, get this into y equals mx plus b form. We have to figure out how to find the slope and how to find the y-intercept. So the slope, I'm going to think of it as change in y over change of x. So my change of x, I'm going up 1. So change in x is 1. And the y, I'm going from -9 to -5 would be +5. So that'd be 5 over 1 is my slope, or just 5. So my slope is 5. Now, to find the b, you could plug in a point. You could plug in a point like 3, 11, 3 in for x, 11 in for y. What I'm going to do is I notice the y-intercept is when x is equal to 0. So I can tell -4 is my b value. So our equation is just going to be y equals 5x minus 4. Sometimes when you're given a table or given points, the y-intercept's in there because it gives you the output when x is 0. That's the y-intercept, so you don't have to do any more work. If you notice that, boom, just plug that in for the y-intercept. So number 6, a car is leaving Albany and traveling to Buffalo. The equation d is equal to 280 minus 59t can be used to represent the distance d from Buffalo after t hours. In this equation, what does 59 represent? So 59 is getting multiplied by t hours. So if I take a look at this, the car's distance from Albany, that's not going to be the case. That's going to, and then let's take a look at, so speed of the car, that could be it. How about 3, distance between Buffalo and Albany? So that's how far we're starting away, which is actually 280, so that's not going to be the case. Number of hours driving, no, that's t, that's not the case, so it would be the speed. Also, if you think about it, if you're multiplying a number times the amount of hours you're driving to see how far away or how close you are to another location, that's the speed. So if I go 60 miles per hour for 2 hours, I traveled how far? 120 miles. So that's going to be the speed. And what does the y-intercept represent? Well, the y-intercept, you can also think about it as the starting point or starting value. So that is, we're starting in Albany and we want to go to Buffalo. So that is the distance the car in Albany is away from its destination in Buffalo. So it's how much we're starting out away from Buffalo in this case. And that would be 280. Doesn't say miles, but it's probably miles. So, number 7, in 2013, the United States Postal Service charged 46 cents to mail a letter weighing up to 1 ounce and 20 cents per ounce for each additional ounce. Which function would determine the cost in dollars y of the mailing a letter weighing x ounces, where x is an integer greater than 1? So we know no matter what, the flat rate is going to be 46 cents. So that's what we're going to be adding on. So I'm going to cross off anything that's not just adding on the flat rate. Adding on the flat rate, that'd be 3. That's not adding on the flat rate of 46 cents. Okay, so now we're down to 2 and 4. Well, if you take a look at that 20 cents per ounce for each additional ounce, that's not including the first ounce. The first ounce is 46 cents, but after that, it's 20 cents. So we need to account for not counting that first ounce. If you take a look at 2 and 4, the major difference is the x minus 1. That x minus 1 is subtracting the first ounce from the total ounces to get how many ounces are additional. So that would be choice 4. So the rest is just practice, and this is homework where we don't finish.